Hello everyone. Today in this video I will show you how to use negative sequence directional element relay. In my previous video I have shown you how to extract positive, negative and zero sequence component for voltage signal, and I did not change anything, just I take this current and then extract positive, negative and zero sequence component for current. I need to use it here. Here INM for negative sequence magnitude, NP for negative sequence phase, VNM for negative sequence magnitude for voltage, and for phase here I will get a trip signal, and here this is for positive sequence magnitude. So here I will show the plot, and INTZ2 I will get it from internal output variable and negative sequence impedance. So if I run my system, look here I have a fault. It will appear after 1 second. It is my forward fault, and this is my reverse fault. So for forward fault I will get a output is 1 if my circuit my relay works perfectly, and I will get -1 for this fault if my relay trip perfectly. Here it is written the output will be 1 for forward fault and -1 for reverse fault, and I'm taking all element from here, IL1, VL1, 1. So that's why it is my forward fault, it is my reverse fault. So line angle, so from here I can get my line angle. Here is 1.18 R and XL 4.35, and my line is 50 kilometer. So let me show you the calculation. So as my line is 50 kilometer long, so I will get X 21.75, R 5.9. So from here I will get the line angle 75 degree, but I have to convert it to radians. So I will get 1.31 radians. So let's set it to 1.31 radians. So, and a few more things we have to check. So what it is saying that forward overcurrent setting 3I2. I2 means like negative sequence current must be greater than this setting. So we will set something, and the current we will get from negative sequence must be higher than this setting. For reverse current also it is the same. So we have to find out forward overcurrent setting and also reverse overcurrent setting, and Z2 would be negative sequence impedance must be less than. So we have to set something higher than negative sequence impedance, and for reverse threshold we have to set something greater than this, less than this value, and I1 is the ratio of negative sequence current and positive sequence, and this ratio must be higher than our stated value. So let's see, as I told you that at 1 second we'll have forward fault. So let's see what is the forward for negative sequence voltage and current. So negative sequence current is like 0.44 something, and voltage is like 13.36, and this is like 0.820. So for INM, like as I said, that 0.48230, and VNM 13.36. So our forward overcurrent setting must be less than this value. So we can set it like around 1, so it might it is less than 1.33, 1.44, and this setting. So look here, we will get the impedance is like minus 27, so we have to set something higher than that. We can set minus 20 or 0, something like that. So we can set it like minus 20, we can set, and this vector. So there is a something like we have to set the value in between 0.0 to 0.5. Look, from here, from the calculation, so it is the positive sequence current, it is the negative sequence current. It must be less than 1.34, so we can set like 0.5. We can set for 0.5, and so, and let's run our system. So look, our system is working perfectly for this case for forward fault, but look, it is not working for negative reverse fault. So we have to set this too. So for reverse fault, our current is like 0.502 and 0.0052. It is 23.990. So look here, INM 0.0052, IPM 1.15935, VNM 23.90. So we have to set this reverse overcurrent less than this 0.0156. So we can set 0.01, 0.01, and what else? And the ratio, look here, the ratio is now 0.03. So if we set 0.5, it must be higher than this value. So we have to set less than this. So we can set 0.02. And I have to set here I have the impedance is 4596. So I have to set less than this. So I can set like around uh, 1 1.5 hundred. So look, our relay trip for forward fault, and also look our trip relay also trip for negative fault. And let me show you the impedance. So as I told you that the impedance is like around 4.5 or 1000, and here it is like around minus 25 or something. So in this way we can set our value, but you have to be careful when set this value, as I showed you just for only one case, like line to ground for or double line to ground for. But maybe you have to tune a little bit for all types of fault, because some of fault are more sensitive. So in that case you have to set it more carefully, but the calculation procedure is all are same. So that's all for today, and I will upload the file in my GitHub. and I also add in the comment section, in the description section. So see you next time.